Hi, everyone, and welcome to this webinar. I'm so excited to be joined by two incredible speakers here today. Here with me is CTO of Nobl9, Nauda, and Imaya Kumar, who's a principal solutions architect at AWS. I encourage everyone to stay until the very end of the session to participate in the Q&A session. There you have the opportunity to ask the speakers about slides or different questions that might come up during the session. Make sure to send your questions either in the Q&A function that's on the Zoom webinar or in the chat. And I hope you enjoy this webinar. Alex, whenever you're ready, take over.
Great. Thanks, Urza. Yeah, so we're here to talk to you today about how at Nobl9 we optimized our metrics using Amazon Managed Service for Prometheus. And we'll talk a little about how we've gone through that. We're an AWS customer. We're also a partner, but I'm really talking to you today as an AWS customer. We host our SaaS instances of Nobl9 on AWS. We'll talk a little bit about why we're on AWS, some of the business use cases for observability and SLOs, and the way that works out for us on the Amazon platform. And I'll then talk a little bit about the challenge we were facing in our observability stack as our company evolved, as our business has grown. Some of the problems we faced, the solution related to Amazon Prometheus, and then some of the outcome and benefits. So also as an AWS customer, we followed, I think you'll see we followed a fairly typical path of adoption for observability tooling. And we're keen observers of how our colleagues in this space are managing their operations and observability. And mainly, I'll talk about SLOs and how we use SLOs, how we use our own SLOs, but I'll also talk about more generally what our challenges were in the observability space. A little bit about Nobl9. Nobl9 is a company dedicated to service level objectives. We have a SaaS offering that is kind of like a cheat code to implement service level objectives. You might think of it almost as a sort of low code implementation of service level objectives that can speed up adoption, setting reliability targets for modern applications and also for legacy applications. We also cultivate a growing community around SLOs with things like OpenSLO, which is an open standard for interoperability. Basically, we took an early version of the Nobl9 schema for SLOs that we use in our YAML and in our Terraform provider. And we open source that. Now it has a mind of its own, and it's growing and has some adoption from other players in the space, some observability tool players in the space, as well as companies that are using it to help implement service level objectives. We also have a development lifecycle we call SLO DLC. And it stands for development lifecycle, but in a way, it also stands for downloadable content, like in a video game, DLC, because it comes with a variety of templates and tools to help companies roll out service level objectives, to define them, all the things that are outside of the product, but that you need to do to run projects around service level objectives and implement them. And also, we are fans of the space. We follow the literature of service level objectives and the state of the art around it. My colleague, Alex Hidalgo, wrote the book, Implementing Service Level Objectives from O'Reilly. It's a great primer. If you haven't read it, you should get a copy. It's really a wonderful way to get an introduction to not only what service level objectives do, but also how you can implement them, where to start, with lots of practical advice and examples in there from his time at Google and at Squarespace, and that we're using now at Nobl9 and with our customers. This should say Nobl9 drives enterprise-wide adoption of SLOs. Nobl9 is a dedicated platform for SLOs. And here's a high-level view of some of what it provides. So we layer on top of existing observability platforms and services. You can see some of the ones, we're highlighting some of the ones that we support on the AWS platform, including Managed Prometheus, but also CloudWatch, OpenSearch, and Redshift as some highlights of what we have in the Amazon environment. We also support a wide variety of observability tools, whether they're like APM or logging tools or metrics tools, including some more legacy stuff. You can see a full list of these on our website. We're launching new integrations every day. And we make it as easy as possible to get data, to create an SLO, to set an SLO, to watch how your services are doing, to visualize those SLOs, annotate them, report on them, et cetera, to manage SLOs as code in a GitOps workflow. So we have specific tooling, both our own CLI and Terraform, to manage SLOs right in your GitOps and CI/CD pipeline. We have a business-friendly service health dashboard to help you take SLOs beyond just your engineering team and your ops team, your app dev teams, over to business stakeholders such as a product team, business stakeholders, including customers potentially. And we have a very service-centric error budgeting and alerting process. Then in order to make the SLOs actionable, we provide alerts into a wide variety of stuff. You can see in here, we have like chat ops tools and alerting tools, also ticketing and service management, ITSM type tools, as well as really flexible webhook that can reach pretty much anything out there, and data export to popular data lake systems. So we really try to close that loop of making your SLOs as actionable as possible. And what this results in is, in service management, we really can provide three main use cases with the SLOs. And once you dial in an SLO, you get this stuff pretty much out of the box. You can use it for incident response, like alerting and alarming, tying into your existing or newly built incident response systems. Second, a planning process of using data and shared data to drive decisions around your roadmap, maybe your sprint planning, release planning, however it is that you drive your IT processes. And then finally, you can also use SLOs in a more longer-term retrospective way to plan your investments across your portfolio of systems. Things like looking at which services are doing well, which services are suffering for whatever reason, which services require some investment, need to be sunsetted, need to be replaced, et cetera. SLOs are useful for all those things. And the beauty of the SLO is, once you dial it in for any of these use cases, it works for all the use cases. And our users see a lot of lift around these things. Main point is we made some significant changes to our observability stack. And one of the results of this is that we were able to reduce our overall observability spend by over 20%. It depends on what environment you look at, how you calculate it, but we were able to significantly reduce the cost of our observability stack. We didn't require any migration downtime or a loss of continuity. We're able to add functionality and get a really good scaling model on our observability stack by moving over to Managed Prometheus. And I'll give you some ins and outs of how that actually went. I'd like to hand it over to Imaya to talk a bit about what AWS has to offer in terms of observability.
Thank you, Alex. Can we go to the next slide? Yeah. So let's be honest here, right? There is no system in the world that is going to be 100% failure proof, right? Like our Amazon CTO, Werner Vogel, says, everything fails all the time, right? We have to expect that. We have to be smarter and basically accept that systems are going to fail eventually. So we know stuff breaks, and for different reasons, and no matter how well it is designed, it is just nature. Okay, and what we have to do is we need to build systems expecting that those failures and build it in such a way that we can recover from failures quickly and hopefully cause minimal damage to the business. But if we want to do that, of course, you have to design your applications to be reliable and scalable and secure and so on. But one of the ways to do that is to, probably build a microservice-based architecture that is completely loosely coupled, that allows you to minimize the blast radius of an impact or downtime. It is easier said than done. Now, all of a sudden, if you have a microservice architecture, you're going to deal with a lot more complexity in terms of the service-to-service interaction, different kinds of logs, and how the different endpoints. There's a lot of moving parts altogether, right? There's a lot of challenges there. Just managing that and trying to understand what is going on in these different services is really challenging. But if you and it could actually make your situation a lot worse than maintaining maybe a big monolith. So you need to have visibility into the performance and health of the services. Let's go to the next slide, Alex. So if you want to do that, observability comes into play, comes to the rescue here. So what exactly is observability? Observability is basically a term that originated in the control theory space. See, basically what that means is, this is going back to in the 60s, right? So basically what that means is you being able to understand the internal states of a system by observing the signals the system is emitting externally. Like, for example, if you're looking at a car engine, so if it's overheated, if you can feel the heat is you measuring through a thermometer. If you see that heat is more than what is expected, that basically means the engine there's some trouble in the engine. So heat is the signal here, and the trouble, you being able to understand what is going on inside the system, is basically the actual state of the system that is inside. So when it comes to systems like in computer science, observability basically means you being able to understand the performance and health of your services. It could be your CPU utilization, your memory utilization, your application failure rates, your service latencies and faults and so on. And you being able to understand what is exactly happening when a system is facing an issue by being able to correlate different signals. Those different signals are essentially, if you could go to the next slide, Alex, logs, metrics, and traces. Okay, so logs, metrics, and traces are the essential signals that you would want to collect from your environments. And these are different types of signals. They give different types of inputs to you. And it is important for you to understand what those signals actually mean. Like, for example, logs are basically time-stamped, contextual, text-based information from an application that would give you the context of an application execution. Whereas when you look at metrics, that is time series data. The simplest one that you would easily understand is CPU utilization, memory utilization. That basically gives you whether the resources that you have allocated to your service is being used effectively or not. Or maybe your application using more or needs more resources than that is allocated. So because of that, it is not functioning well. And traces are the more recent, or probably the more advanced type of signal. That is basically very important when it comes to a microservice-based architecture, like mentioned before. You really want to understand what is happening between the different systems. When you have a system that has, let's say, 10 microservices, that's really small. These days we build systems, the more complex systems have hundreds of microservices. But if you have just, let's say, 10 microservices, that basically means you have all those different services that are potentially written using different programming languages, different frameworks, and they are being hosted in different environments. Maybe some could be on Amazon ECS and EKS, and could be Lambda functions and App Runner and so on. And all these different microservices can function differently because of the nature of their computer environment they're on. But you really need to know, as a business user, they don't care where your application is hosted. For them, all that matters is, for the business, all that matters is whether the business is functioning the way they expect. is performing the way the company expects the business to perform. So if there is a service to service interaction issue, there is a service latency going on, traces are the one that's going to tell you, because that actually captures the interaction between the services and will give you information about how the service to service interaction is. So the true observability comes together when you're able to put all this information together and correlate all the data and understand what is going on in your system. So if an issue, if a customer is complaining about their service being slow or website being sluggish or causing errors, you should be able to understand whether it is through because of an application code issue that through logs, or it could be an infrastructure issue, resource allocation issue that could be visualized through metrics, or it could be some kind of a configuration issue that is causing through traces, or maybe a core issue that could be identified through traces. All that information should be presented to you together in advance, so you should be able to correlate and understand the root cause and eventually reduce the mean time to resolution. Okay, let's go to the next one, Alex. When it comes to AWS options, AWS services, we have AWS customers. If you look at them, they range from really tiny startups that started last week to big, large enterprises, and also the startups that were startups 2 years ago. Now they are big companies that are providing immense value to their customers. The range, and they do different things. There are companies that do banking and media, and you can think of all the different kinds of stuff that AWS customers will typically do. Their necessities are different, their needs are different, and they're structured differently. And they're not all applications, by the way, need to have 100% availability either. So that's something that we all need to be aware of. So what I'm trying to get here is that customers' need vary, and they have different needs, and that the goals are different. So based on that, because of that, we have different options for customers to choose from. We have AWS native observability services with CloudWatch, and then we have open source managed services with Prometheus, Grafana, and OpenTelemetry, OpenSearch, and so on. So with CloudWatch and X-Ray and the platform that is on there, so you have a lot of features that you can use to monitor your network, monitor your applications. You can use synthetic monitoring through CloudWatch Synthetics, do real user monitoring through RUM, and so on. And there are purpose-built specific features such as container insights, Lambda insights, contributor insights, and so on that are specifically built to solve a specific use case. And on the open source side, there is this Managed Prometheus service that is fully Prometheus compatible, PromQL compatible. You can use to collect tens of millions of metrics from your many workloads, and you can visualize all of that through Grafana and so on. So by the way, these services are not mutually exclusive. You can use either one. You can use CloudWatch for metrics, OpenSearch for logs, and Prometheus for metrics, and visualize all of that in Grafana. So that's the power of all the observability services that we have. Let's go on to the next one, Alex. When it comes to the business use cases for observability, it is really, in some ways, it is common sense. You just want your systems to be highly available. You want to be able to quickly identify issues. You want to deploy more faster, more often. That becomes much more critical for developers, because when you look at a microservice architecture, the developers, maybe they are polyglot systems. So you have developers developing these systems in different languages. And because they're small, you're able to deploy faster. So that basically means you might cost more. There are more opportunities for you to cause for issues. That basically means that you have to set up better observability and so on. So there are a lot of advantages for you to set up better observability, and ultimately it is the business that would that gets benefit from observability. But the responsibility of observability itself, in my opinion, lies with the developer. Developers need to instrument the code properly and be very intentional about what they're instrumenting and how they're instrumenting and where they're collecting that information, and also know what specific data to collect to ensure that that in case of an incident, they're able to troubleshoot and resolve properly. Let's go to the next one, Alex.
Can I just interject here? We have the same use case. We're like every other company, right? We have the same exact use cases. We want to keep our systems up as much as possible. when there's an incident, when there's an issue, we want to research it and get to the bottom of it as fast as possible. Of course, we want to deploy more often. We want to keep our carbon footprint down. We also want to keep our costs down and be efficient across the stack. Very, very much what we were looking for as well.
Absolutely, absolutely. Yeah, we see that, like I said, in companies of all sizes, it's just the underlying theme is exactly the same. We just want our systems to be highly available, and also we don't want to spend too much time in troubleshooting an incident and get back to business on time. So that's the ultimate need. Okay, so how can you use observability? Obviously, there are a lot of advantages for you when you set up observability. There are a lot of use cases here. One of the important things that we want to talk about, particularly in this webinar, is SLOs. SLOs are service level objectives. SLOs are essentially a target set for a given system's desired consistency of behavior over time. If a system or service is not meeting its SLO, there are consequences such as performance degradation, outages, or impact on customers. SLOs are essentially a target set for a given system's desired consistency over a period of time. Okay, so SLOs balance the possible negative repercussions and the lack of availability to determine a reasonable uptime goal for that service, with the downtime afforded in that SLO as the error budget. So SLOs are one of the most important use cases here when it comes to observability. While setting up observability itself adds a lot of value in terms of some of the unrealized things, like something that you may not even be thinking about, for example, like tool consolidation. Like tool consolidation is you may not, by setting a better observability, you might be able to understand that there are a lot of varied tools that are not adding too much business value, that you may be able to eliminate and actually consolidate into a much more smaller subset. Let's go to the next one, Alex. Next slide. Okay, so what are SLIs, SLOs, and error budgets? We mentioned about that in the previous slide. So these are the terms and concepts we use to describe what's going on as you seek to deliver better reliability and performance, and how to make sense of everything. The three terms, SLIs, SLO, and error budget. These are the three important terms that we're going to discuss, again and again in this presentation. So SLI is basically a metric observed at a given moment. You can think of it as a KPI for something you want to track. In this example that you're seeing on the slide, you're using request latency of less than 5 seconds as the goal. So if your SLI is true or false, whether or not your request latency was less than or more than 5 seconds, it is basically a single data point. Right? An SLO is a way to measure your SLIs over a period of time. In this example, you can say that over a 14-day period, you want to achieve your SLI latency of 5 seconds or less at least 99% of the time. So you can look at those true or false conditions of the SLO, and if 99% of them are less than 5 seconds, you have achieved your objective. So your error budget, that's the other term. Error budget is how many negative events you're willing to have before you think customers will notice and complain. So no one can guarantee a system will always be running perfectly 100% of the time. We keep repeating this again and again, which really want to drive this home. So you really don't want to strive for that. It's probably going to be impossible. But if you want to find the right level based on user expectations, that's really important, right? So, and this may not even be 5 or 4 or 3 nines, because as you approach these levels, the cost to achieve them becomes prohibitive. In this example, we have chosen 99%. So as long as you are spending less than 1% of your error budget, then you don't need to do anything to fix reliability, because your customers are unlikely to notice and or complain. But if you exceed that error budget, then you want to spend time fixing the issues that negatively impact that reliability and divert your attention from adding new features to fixing what's already released. So So it's for us. It's really important for us as folks who operate the systems to really think about what is the right SLO for my service, for my application, and what are the indicators that I need to pick to ensure that I track my SLOs are within the limits that I want it to be. And also the tolerance level, which is basically the error budget, is something that you can either determine based on your business inputs, your business team saying what is the tolerance level, and they would determine based on the criticality of the applications and so on. So it really depends on SLOs, SLIs, and error budgets are really very specific to specific workloads and applications. It cannot. It is not an app or company-wide or industry-wide number that is typically taken in. Let's go to the next one, Alex. All right, so I think with this, I will hand it over to you.
Sure. Thanks for the overview. And by the way, folks, I just want to point out that if you're interested more in SLOs, that talk by Jan Ritter is really good intro to SLOs. If you're not familiar with it, we're going to assume from here that you're fairly familiar with SLOs as a concept and are interested more in how to apply them and maybe what it means for your observability stack, right? Which is what I was dealing with in this project. So here, this is a very high level view of what the Nobl9 application consists of. Okay, this is what I'm actually trying to measure and trying to monitor with our observability stack, our metric stack, and our monitoring. And in here, you can see a single instance of Nobl9 runs mostly inside of an EKS cluster. Here's the VPC of that EKS cluster. We run across 3 availability zones. There's a bunch of EKS nodes in there. Each of those availability zones has a NAT gateway and an elastic IP address that any outbound requests originate from. And then there's a bunch of other stuff alongside that main compute in the EKS cluster. We got a couple of RDS databases. We have an EFS file system. We got some S3 in here for point storage. We're storing a lot of metrics in a lot of different places. We also have some integration with our customers' networks. We offer private networking in some instances into the VPC, so they don't have to put their data on the internet, right? Our customers, that is. And we also offer data export out to our customers' cloud storage bucket, typically S3 in the Amazon environment. This is, to a large extent, what we need to monitor on each of our Nobl9 instances at Nobl9, right, in order to keep the application running. I would say when we set out to wrap this system with observability, there were sort of 3 main use cases that categories of use cases we were worried about, like operations. In other words, looking at, is the thing running, is it healthy, right? Alerting. So we needed to set up some monitoring on there to tell us when something goes down, when something's out of whack. And then of course, SLOs, because we like to eat our own dog food or drink our own champagne, as we like to refer to it. And so for us, SLOs are a major, one of the major outputs of our observability. And when we set this up, we followed what I would describe as a really traditional pattern, right? We went with a central observability platform. Our developers already knew it or had worked with it in the past. It was really intuitive to set up, and it was really inexpensive to get started, right? You just drop this. I think in our case, it was like a deployment, or really it's a daemon set that runs across all the EKS nodes and gathers everything and puts it all into a central metric system, which was a SaaS platform. And wow, look, we were able to achieve all of this. It's one of the ones we integrate with in terms of the SLOs, and the operational response and alerting were basically built into that, right? You must see this kind of thing all the time in Imaya, because this is a pretty standard journey we went on, right?
Yeah. So this is again like like companies of all sizes, right? We see that all the time with our AWS customers. Similar challenges, similar issues, and the goals are similar, which is just common observation that we have. Yeah.
Cool. Yeah. We do have more than just that. So here's an abbreviated version of that diagram I just showed you. Alongside that, we have two major upstream providers. One is Okta. We never wrote a login page. Finally, I was able to write an application and never write a login page. We outsourced that to Okta from the very beginning, and they also provide our SSO and access key sort of functionality. And we also have a time series database that's basically embedded in our system, but it's run as a SaaS platform by InfluxDB Cloud is what we're using here. Both of those are also hosted on AWS, but through another vendor, right? And basically what we set up was this traditional metrics platform that pulled in metrics mainly from our stuff. Like I said, from a daemon set running in here. We hadn't instrumented that on the external providers really in any usable capacity. The other thing is because we're on AWS, of course, we also have CloudWatch, right? You may have seen earlier that I'm also monitoring via CloudWatch our application load balancer that's in front of this instance. And we have AWS WAF on there. And there's a bunch of bits and pieces that are where CloudWatch is basically the built-in monitoring. As I mentioned, Nobl9 itself is a major destination of this. So we're running another instance of Nobl9 alongside this to do our monitoring and for our SRE team, for our software engineers, but also for our product team and our other stakeholders in the business. Those SLOs are a key way that we manage things. Okay, so these arrows into Nobl9 to track SLOs are important arrows for us. We do have an integration to both that central platform that we chose and CloudWatch, so we were able to pull that in. But we did have some pain points. In particular, we never had set up coverage. It might have been possible to wire up coverage of both Okta and InfluxDB Cloud into our traditional metrics platform or maybe CloudWatch. We hadn't really ever wired it up. I don't know the most straightforward way of doing that, but we wanted to find a way to instrument that. But then also on the central metrics platform, what we found was there were two main categories of issue. The one was we found that it didn't quite cost scale the way that we hoped. It got more expensive faster. We hoped for better economies of scale as it grew. And partly it's that we're just using all the features and we're throwing all kinds of custom metrics in there and it kind of ran away. And it grew really fast and we started to have to manage that. And we were looking for ways to reduce it. The other piece is that traditional metrics platform wasn't as code, everything as code, infrastructure as code as we like. We're very GitOps and IAC focused. That's just how we like to do everything. We like everything to be a pull request. And it felt in that central metrics platform that we chose, it felt like it was kind of an afterthought. It was kind of bolted on to the side of it and you could kind of get it working, but we had set up a lot of it with what we call ClickOps. We just got in and kind of wired everything up. And we were missing that aspect of being able to manage the changes and review the changes and promote across environments the way we wanted. So to sum that up, basically what we revised our requirements on what we were looking for in our metrics platform. And what we decided we're looking for is very low management overhead. We want it to be as turnkey as possible because we have a small team and we can't deal with managing something all the time, okay? We wanted it to fit with our distributed environments because we have a bunch of dev environments, staging, production environments, etc., right? We wanted it to be intuitive to set up, particularly for our software engineers and our SRE team. We wanted a overall total cost of ownership to be lower, especially as it scales. And we wanted it to be somewhat future-proof. That is, we don't want to have to either scale up a bunch of stuff by hand as we grow or negotiate a bunch of pricing contracts or something as we grow. We wanted something that would scale reasonably as we grow. And what we found was that with Managed Prometheus, in particular with Amazon Managed Service for Prometheus, it fit those needs to a T, right? It was completely turnkey. As far as the distributed environments, it's based on Cortex. In fact, we know this because AWS contributes patches upstream to Cortex. It's a proven technology. It's a really great way of federating your Prometheus metrics. It's intuitive to set up, partly because all the collection tooling, the stuff that actually sits inside the cluster, is entirely open source and very widely adopted. So, endless Stack Overflow ability, right? And guides and recipes and even expertise already in-house that people are already familiar with. It is a significantly lower cost, partly because AWS has kind of commoditizing essentially this space of metrics, which is great. And it scales really well. It's usage-based pricing and very low management overhead. So we decided, let's move our metrics into Managed Prometheus. What does that actually look like, right? At a high level, it's just, we just swap it in and the arrows on the diagram are the same, right?
And you had to just remote write into Managed Prometheus service, and
yeah, and I'll go into some detail because there was some tooling and instrumentation needed in the cluster. So I'll talk through that piece. But we basically found that to a large extent, for the metrics use case of observability in particular, we were able to more or less drop it in. Again, Nobl9 has an integration to lots of flavors of Prometheus, including Amazon Managed Prometheus, and CloudWatch is still there right alongside it, tracking the stuff that automatically reports to CloudWatch. So it's pretty seamless for our users, consumers of the SLOs to look at this. There is a need for the developers to get familiar with using Managed Prometheus or a Grafana on top of it, let's say, to do problem resolution, looking at metrics when an incident is going on. That was also very palatable to the developers. So it was a pretty simple thing to do. Now, I want to walk you through a couple of specific use cases where I can show you what the basically what some of our SLOs actually look like on these. The first one I'd like to speak to is what we did with Okta. We didn't actually instrument this directly on Okta. We have a user management API that is basically proxying all the calls we make to Okta. And we were able to instrument metrics on that user management API that really measure how exactly Okta is behaving for us, given the way that we use it, the calls that we make against it. Our customer traffic is scaling up. And so we wanted to make sure that we handled that. Now, I'm just going to have to pause the share for a moment. Just give me a second. I'm going to switch over to Nobl9 and just give you a glimpse of this. I'll give you a glimpse of this metric. Anybody have a joke handy while I'm just rearranging my environment here? Just give me a second. Yeah, just trying to set it up so you get a good view, because I think that my screen I have a big screen and you're not gonna be able to read it. Let me just share this window. Yeah, so here's an SLO in Nobl9. This is the user management API. This is actually on our production data. And in here, you can see a view of this SLO. So we have a service level indicator coming in. It's measuring request duration against a specific subset of those Okta calls. And you can see that we have some thresholds in here set up, one at what we call reasonable at around 1/3 of a second, and one at slow at about 1/2 a second. And if I zoom into one of these places where we have a violation of that threshold, you can probably see how it goes. You can see the SLI was fine. It kind of crept up above the 1/2 second mark, right? And if you look at this, the numbers that appear here, you can see our reliability in this moment, in this 10-minute period or so, dropped from 99.8 to 99.79. It's just eroding a small amount of our error budget. There's a corresponding burn rate here related to that. This is really reasonable. In fact, when we put this in place, I was delighted to see that it was as good as it was, because we were worried. We had some, we would see these violations, we would see these spikes, and we'd see those alerts, and we weren't really sure, well, how bad really is it? And when we really set up these targets and we said we want it to be 95% of the time better than this, we can tolerate a few slower ones on a user management page, we found that it's actually in a really good green zone. We were delighted with that. The next piece was we wanted to look at our data intake API. So when you think about Nobl9, we have users, and of course there's a user management page. That was mostly interesting because it was an external dependency. But if our system has one job that it has to do constantly, it's that we have to take in data and calculate SLOs on it, okay? We're continuously receiving this data from telemetry, from our agents and direct connections, agentless integrations with our customers' data sources. We need to continually receive that data and share it, calculate charts from it and share it back out to our customers. That is data intake. We have a couple of flavors of data intake. There's an agent data intake and a direct data intake. As I mentioned, we have this agentless generation. The data intake is, look at it, it's completely green dial tone. This thing will go down if intake goes down. We try to make sure that system stays up constantly. It also serves up configuration to the agents. And on the configuration, we're actually currently failing in an SLO. This is a slower request. It's doing a lot of work. And you can see that good is less than a second, slow is less than 2 seconds. We're definitely hitting the slow less than 2 seconds, but on good, we're not hitting our good SLO on this. It's not the end of the world. I think we're having a conversation about this now, about what is the proper target for this SLO, what is the proper threshold for this SLO. But you know, in the what we would call is it slow question, the answer is no, it's not really that slow. It's just not quite as great as we wish it was. I'm really happy to have this, you know, as a way of measuring that, to kind of enable that conversation, especially when it's not clear exactly what customers would need, right? And then the third use case is Kafka processing lag. So as I mentioned, we're receiving this SLI data constantly. Once it arrives at our system, we need to calculate certain things from it. We're calculating all these charts and graphs data, basically. You can think of an SLO as a series of time series. And we store the time series we get from telemetry, the SLI. And then we calculate from it the SLO value, burn rate, all these other things. There's a bunch of alerting calculations and things. And to do our job properly, we need that to also operate continuously. And the way that we mainly measure that is this processing lag. So if I look at the way that one works, you know, we set up an SLO on processing lag. This also has generally been doing quite well. And you can see in the current window, I'm using a 7-day rolling time window for this. And I want 99% of the time for this processing lag to be under 2000. That's 2000 points or messages coming through that. And actually, if I scroll back, I can go back maybe month by month and look at it. There are times when it spikes, okay? This could be because we did some maintenance on the system. Maybe it took longer than we thought and it was down for longer than we hoped. It could also be that, you know, we had an actual outage, right? At one point, we could do another session sometime, but we actually run Kafka in our cluster and we brought Kafka down. That's a different story that maybe we could talk about over a drink sometime. But you can see up here, this actually went up to a very high number, a very high lag, nowhere near 2000. We went up to almost 800,000 lag. Of course, we brought it down, or we brought it back up in what looks like a reasonable amount of time. This was about a month ago. And so this gives us a good way of monitoring this stuff. I would say this is something that we're constantly watching. We're making sure that when we do have a spike that we recover quickly. You can see we actually had made some code changes here and we were having some issues. We made a significant performance improvement to how fast we can recover from these. And we had a similar spike that actually went, again, very high on this chart. But you can see we lost a lot less reliability because we were able to recover from it a lot faster. And so not only does this help us manage like, hey, what is the impact we're having on customers, but also when we make a change and we try to improve that and adapt to it, can we now stay within our goal? And we did. It looks like in this event, we went from 100% reliability down to 99.4, which is within tolerance, right? That's within our leeway. And as long as we recover from that within a reasonable amount of time, and we don't do this like every single day or within the same 7-day window, we'll recover from it. So hopefully that gives you an idea of how we're using these this observability stack in our SLOs. Let me tell you a little bit about what it was like, because it's not only about where we ultimately arrived in this, it's also what it was like for us to get there, right? There's a lot of risk in changing your metric stack. And as much as we focus on where we got, we need to know what it actually took to get there. So our number one rule is, let's not disrupt our current operations. We wanted to transition gradually. Fortunately, we were able to do this in parallel, a few services at a time. We were able to incrementally move it over, and it went really smoothly. Our first phase of this implementation went really smoothly. We're now proceeding incrementally through the rest of our stack and our environments. There was some minor retooling required. I would say there's 4 levels of complexity. These are kind of in increasing order of complexity. The first thing we found is that many systems had a Prometheus exporter, like Kafka. It's got a Prometheus exporter. You get all the JMX metrics from Kafka, and you can also get things like the lag metrics out of there. And that was a no-brainer. You drop the Prometheus exporter in there, and it was no code change needed other than to add that Prometheus exporter. The next level of complexity was some of the applications can be auto-instrumented. So depending on your language stack, you can drop a Prometheus exporter into your, maybe it's an add-on to your REST API routing framework or something like that. And it was super lightweight to do, and we didn't really have to do code changes. It was more like add a library, rebuild, test it out, and it worked fine. The next level of complexity was instrumenting a backend. We actually instrumented some of our backends with OTel. This is pretty easy to do on a backend. There's some minor code change instrumentation needed where you're going to instrument a custom metric, but even that was pretty lightweight. And again, the change to the application build was pretty minor. And then the fourth one, the most complex thing that we did that's still underway, is instrumenting a front end with OpenTelemetry. The instrumentation on there is pretty easy, but one of the reasons I listed it as more complex is that we did have to expose a place to track those metrics, because if you're tracking that, let's say in a browser application, you need to send the metrics somewhere. You have to phone home with those metrics somewhere, and that required an additional endpoint and some security stuff. So it was a little bit more complex. But again, overall, this is not that different from any commercial or open source tools on the market. We were able to get it up and running relatively quickly, and definitely worth it when you look at the cost savings there. Just I had said earlier, this was like a 20+% reduction in cost savings. What it really looks like is that the infra spend, as a portion of infrastructure spend, the previous platform, the central metrics platform, was costing us between 12 to 30%, kind of like a tax on top of our infrastructure. So we're paying all this stuff for EC2, et cetera, and at a minimum 12% more on top of that for the observability, just for the metric stack. And now we got that down to somewhere between 4 and 7%, depending on environment. The bigger environments scale better. The smaller environments, maybe it costs a little more as a total portion. And as I said, minimal application code changes. It was completely incremental. It was doable with infrastructure as code, which we loved. And we feel like it was more consistent with our overall technology approach and our ethos.
And Alex, actually, we do see that at AWS, like we see customers wanting to kind of move towards particularly the EKS customers wanting to move towards open source observability and want to leverage the advantages that it brings, right? Well, so other than this, like what other advantages that you see that could make customers take this path?
Yeah, I mean, I would kind of dwell on this consistent with our ethos thing, because this is pretty big when it comes to, you know, how we actually do our job as a software company, right? So for example, when I say it's consistent with our technology approach, everything in this stack is GitOps, everything's a pull request. And that just feels so refreshing compared to what we were on before. That's a big piece of it. The other thing is, again, kind of consistent with our technology approach, this observability space is changing so quickly. And there's new tools all the time and new techniques all the time. And we want to experiment with it. There's a reason these things are popular. Fortunately for us, if we use these SLOs and we can set up an SLO in the old system and the new system and run them in parallel, it reduces our risk, right? So it improves our flexibility to go and try stuff, try out the new tooling, try out a new technique. And maybe best of all is that aside from just the base cost of the thing, we don't have the kind of like billing surprises, right? This, because it's on, you know, the cost of Managed Prometheus is a line item on our AWS bill, which means we were able to slot it right into our existing FinOps process, and we manage it alongside all of our other costs rather than, you know, once a month getting some surprise like, oops, you know, hey, we took this feature out of beta and we're now charging you for it, or you must have something that got really noisy in your metrics because you know, suddenly there's an unexpected cost spike. And so the overall stability combined with that fit with our ethos has just been really great.
Awesome. Nice to hear.
Yeah, so that's our presentation for today. I just want to say thank you to Imaya for joining us for this, and thank you to all of you who are able to attend.